All right, so first thing I would say to make sure you're paying close attention to is the directions in this section, right? Because if it says to restrict the interval, it's going to be a different answer than if it doesn't say to restrict the interval. So you could train yourself to make sure you're reading the instructions. So this one says to restrict the interval from 0 to 2 pi, which means I'm using my entire unit circle. I'm actually going to go to questions 2 and 3 and then go back to 1 because it's a multiple angle and you have to do it a little bit differently. Okay, so for 2, I'm going to factor it, right? So I'm going to get everything to one side. I'm going to do secant squared x minus secant x minus 2 equals 0. And then I'm going to factor it, secant and x and secant x. And then factors of -2, that's 7 to -1. -2, +1. Set them equal to 0. And I get secant of x equals 2. And secant of x equals -1. So because that's the secant, I just flip it to get its reciprocal function, which is on my circle. I don't want to have to worry about memorizing the secants too. And I get cosine is -1 and 1, and -1 and 1/2. So because it told me to restrict it, I'm going to my unit circle, and I'm using the entire circle, and I'm going to find everywhere cosine is -1, which happens here, or +1/2, what happens here and here. And my answers there would be pi over 3, pi, and 5 pi over 3. Now, if it had not said to restrict it to the interval, so if there was no interval there, because this is cosine, I would have taken each of those and I would have added 2n pi. So it's important to know both because you can get both set of instructions on your quiz, or one and not the other.
So that's how I would get it wrong on the homework.
There were two kind of like tricky ones on how you entered the answer to the homework. Like I'll go over those. So it might have been marking it wrong just because of the way you wrote it, but
Yeah.
and there's two of them like that. Yeah, I'll go over those.
I think I put the right answer.
You probably did. There was one that was like 5 pi over 3 instead of -pi over 3. Yeah, it's the same answer. So yeah, I'll go over those when I get there.
So if we put that on our quiz, like instead of
So quiz, yeah, no, I would take either one. Quiz, either one's right. Yeah, yeah. This one was secant and tangent. So the first thing we have to do is get them to be the same function, which would be what? What's easier to get from your unit circle, the secants or the tangent? Interesting. Okay, so I guess it doesn't matter. It's whatever was easier for you because you can sub them both in for each other, right? So one of the Pythagorean identities that you need to know is that tangent squared x plus 1 equals secant squared x. So that's already solved for secant. Maybe instead of having to solve it for tangent, maybe I would pick that, but it really doesn't matter. You get the same answer both ways. Then I would distribute in the two. Combine my like terms. And then solve. So the tangent of x is plus and minus the square root of 1 over 3, or plus and minus the square root of 3 over 3. So it's giving me the interval this time, which means use the entire unit circle. So if I were to go to my unit circle and find everywhere tangent is root 3 over 3, you're going to find it happen at every over 6. So this would be at pi over 6. It would be at 5 pi over 6, 7 pi over 6, and 11 pi over 6. And I use all of those because it tells me to use the interval 0 to 2 pi. If it did not say that, so if I go back over to the right and I said it didn't have an interval, then my answer would have been negative pi over 6 plus n pi and positive pi over 6 plus n pi. Because our first answer, we restrict tangent from negative pi over 2 to positive pi over 2. And for tangent, we add just n pi, which takes us halfway around the circle. So pay attention to the difference in the instructions. Patty?
I did it differently, but I kind of got the same answer.
Did you do the secant instead of the tangent?
Yeah.
You should have gotten the same answer. It should still give you the same answer. As the purple, right? The cosine on the without the interval would be different. This would be different. but this would be the same. Okay, so now let me go back to that first one. So this says tangent of 3x would equal 0, and tangent x minus 1 would equal 0. So the left side's already solved. It's a multiple angle, but it's already solved. This one would be tangent of x equals 1. So I'm going to go to my unit circle, and I'm going to figure out where tangent 0, which is at 0 and also at pi. So then I would get 0. Now this is where it's important, because if there's a 3 there, I know I'm going to have to set 3x equal to this. So it's 0 plus n pi. When you have the restricted variable, this is where it gets a little bit more complicated with the multiple angle. So when I have this and the multiple angle, this is where it gets dicey because you have to add the actual intervals. Yep.
Wait, I thought we were not adding the n pi.
So if it, okay, let me look at the one on the right. If it says just tangent of x equals 1, then my answer here is pi over 4 and 5 pi over 4, and I'm done. But because this has a 3 next to it,
And they divide the 3.
I do, but it could happen more frequently than what's happening on my circle, which is why you have to account for the interval. Even though the answer is not going to have the interval in it, you have to account for it. Because I'll show you what's going to happen, right? So if I did that, it happens at 0, and it also happens at pi. If I take and divide this, I get 0 plus n pi over 3. Here, I get pi over 3 plus n pi over 3. So without an interval, that's my answer. But with the interval, we have to change n to 1 and then continue to add that interval until it gets bigger than 2 pi. So while 0 is one of the answers, I have to do 0 plus pi over 3. And that's pi over 3, which is still smaller than 2 pi, so I have to add it. And then I have to do it again. And that is still smaller than 2 pi, so I have to add it. And then I do it again. And that's pi, which is actually the one from the other side, but I'm going to keep it. Then do it again. 4 pi over 3, still smaller. One more time. If I added one more pi, I'd end up with 2 pi, which is too big. So now my answers are all of these.
So you have to have all of those?
Yep.
I don't understand.
Plus this.
I don't know what you just did.
Okay.
Me either.
Because the multiple angle, right? You get that this is a multiple angle, so it's different than this. You see that that's different, right? The x has something attached to it. Yes? Other than an x or other than a squared, because a squared you just square root. If you have something attached to the x, it's not only altering what it's equal to, it's also altering the interval in which it happens. So instead of it just saying, let's say my initial answer was 0, right, which is what it was. Instead of just saying it happens here and then here, by saying 3x, we normally add n pi, which means I have to divide by it. Which means not only is it happening at those places, but it's happening at every 1/3 pi after those places.
The 1/3 of the n pi.
It's n pi, but then you have to divide by the 3 that's attached to the x. So by doing that, we decrease the amount of the interval, right? So now it's happening here, right? It's happening at 0, and then it's happening at 0 plus 1/3, which is pi over 3. That again plus 1/3, which is 2 pi over 3. That again plus 1/3, which is pi, plus 1/3, plus 1/3, and then it would go back to 2 pi. So it's happening more frequently. We're adjusting not only the angle, but you're also adjusting how frequently it's done. So the good news is that I saved that kind of question for your test. It's not on tomorrow's quiz. But you will see it on your test. So you will see a multiple angle tomorrow, but not with an interval. Not with a restricted interval, because that's where it gets like that.
So I would only have a
So your answers for tomorrow would be actually this, this, and this. Well, actually, it would be 0, plus n pi over 3. It'd be pi over 3 plus n pi over 3. It'd be pi over 4 plus n pi, and it'd be 5 pi over 4 plus n pi. Yep. Because it won't give you the interval, but this came from a multiple angle.
Oh, okay.
For tangent. Oh, right. So these would have been negative pi over 4 and positive pi over 4. But the other side is yeah. What you're saying is right, Nikki. That it would have been restricted from, so it would have just actually been those two. Because we would have kept it from negative pi over 2 to positive pi. No, pi over 3 would still be in that range. That would still be in that range. It's just we wouldn't have taken 5 pi over 4. We would have taken negative pi over 4. So we'll do, hopefully we'll get to it. We'll do one more multiple angle review question without the interval so you can get a better sense of what it is. But that stuff is going to come back again before your test. So you want to keep it in mind. Without an interval, I would have said sine is 1/2 at pi over 6 and at 5 pi over 6. So 3x would equal pi over 6 plus 2n pi, and 3x equals 5 pi over 6 plus 2n pi. And then I would have had to divide by 3 or multiply by 1/3. So I'd get pi over 18 plus 2 pi n over 3, divide by 3, multiply by 1/3. 5 pi over 18 plus 2n pi over 3. And those would be your answers if there was no interval. Okay. If there was an interval, then I would have to take pi over 18 and add 2 pi over 3 to it. So this would be times 6, and times 6 I'd get pi over 18 plus 12 pi over 18, and I'd get 13 pi over 18, and I'd have to say, is that smaller than 2 pi? And it is. So not only would I have pi over 18, but I'd also have 13 pi over 18. And then I'd have to do it again. 25 pi over 18, which is still smaller than 2 pi, so I count that. And then I would do it again, and now it's too big. Does that make sense?
So that would be your last one since it's too big?
Yep. Yep.
Okay.
And I would also have to do it here, though. So 5 pi over 18 plus 2 pi over 3, or 5 pi over 18 plus 12 pi over 18, and I'd get 17 pi over 18, which is less than 2 pi, and then I would do it again.
I said J, but can I do it now?
Sure. If I did it again, it'd be too big, right? Yes?
It would.
It would be too big, so I couldn't count it. This is
I
8.
got
Yeah, I got all of them.
almost every question wrong in the homework.
Well, that's a problem.
I
think there's like 2. There's like
50.
2 that I would say like the format was a little wonky, but the rest of it.
I got a 50. I actually got those right.
All right, so
But I got those right.
what could you do here, guys? First of all, different trig functions, right?
I got the middle two, but the smallest and largest one. Yeah, I know.
All right, so how do I change this so that it? How do I change it so it has the same trig function?
Cosine minus sine.
Good. I cannot replace cosine to the first, right? It has to be the squared one. So this, if sine squared plus cosine squared equals 1, then sine squared would equal 1 minus cosine squared. So I'd get 24 times 1 minus cosine squared x equals 24 minus 12 cosine x. 24 minus 24 cosine squared x. 4 minus 12 cosine x. Then I'm going to get everything to one side. I prefer to keep my squared term positive, so I'm going to move that to the other side. And I'd get a positive 24 cosine squared x. Subtract the 24 here, and they cancel out. Minus 12 cosine x. Then what? Take out a 12 cosine. And I get 2 cosine x minus 1. And then we can split and solve it. So 12 cosine x equals 0. And 2 cosine x equals 1. Cosine of x equals 1/2. And cosine of x equals 0. So it did it give you the interval? Yep, it gave you the interval this time, so I'm using my entire unit circle. Cosine is 0 at pi over 2 and 3 pi over 2. And cosine is 1/2 at pi over 3 and 5 pi over 3. I can give you a blank one if you need it, but I wouldn't even fill in the whole thing if I were you. Yeah, like the question was, are you going to have a unit circle? I will give you, like, I put like 4 on a sheet. So I'll give you like a quarter-size sheet of paper. My advice is to do like, instead of the unit circle, I would even say like over 6 equals root 3 over 2 and 1/2. And then the tangent's root 3 over 3. And then over 4 is root 2 over 2 and root 2 over 2. And the tangent is 1. And then over 3 is 1/2 root 3 over 2. 1/2 and root 3 over 2. And then the tangent is root 3. Like for me,
I disagree.
that's fine. You're allowed to. My advice is not to fill in the whole unit circle. Don't take 10 minutes filling in your whole unit circle. First of all, you've never used the degree symbol in here for these kind of questions. Secondly, if you would just fill in, even if you wanted to fill in like the radians so you know where it's happening, that's fine. But don't waste your time on filling in like every coordinate point and all that good stuff. And then make sure you also add the tangents on is what I would say to make sure you add. No, you'll have time during your quiz. That's why I'm saying don't waste the time.
And it's just going to be 30 minutes, right?
Yep.
Is it going to be a blank unit circle? Or
Yeah, I'll give you a blank unit circle.
Paper?
Blank unit circle.
Okay.
Yeah.
So it
This is
says
what I was thinking.
12 cosine x, right? But if there was a 12 next to the x, would it be a difference?
Now it's a multiple angle one. Now you would figure out your interval, right? So let's say it didn't give you an interval. It would be pi over 2 plus 2n pi equals 12x. And 3 pi over 2 plus 2n pi equals 12x. And then I'd have to divide everything by 12.
As without interval, right?
Say again. That's without the interval. So even though it doesn't give you the interval, you have to add the interval on here to adjust the interval. Yeah. And then the yucky problems would be if it did have the interval, then you'd literally have to take 12 pi over 24 and add to it pi over 6, and then add to it pi over 6, and then add to it pi over 6 until you get bigger than 2 pi. That would be if I gave you the interval, which I will not do for the quiz, but you'll probably see for your test.
For the quiz, how do we write it again?
It would be like here. This would be pi over, nope, because you multiply times 1/12. So pi over 24 plus n pi over 6, like that. And then from this one, 3 pi over 24. Oh, that one reduces.
You said that won't be in our quiz, right?
What I'm doing right now, yes, will be. Those two. She just made it up. Okay, what was it? I get the cosine of x equals 0 and the cosine of x equals 1. So normally the cosine, well, not normally, it always, like, cosine of x equals 0 would be at pi over 2. And this time it didn't give you an interval, so it would be pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi. And then the cosine of x being 1 happens at 0 plus 2n pi. So this one is the larger of the two. No, actually, it's, yeah. So it would have been 2n pi, or 0 plus n pi. That's the smaller of the two, not the larger of the two. Okay. And then instead of giving both of these, which is what I would have taken on a quiz answer, so if that's what you had, don't stress out about it. It basically condensed that, because if it's saying it's happening here and it's happening here, then instead of saying both plus 2 pi, I can simply say one of them plus n pi. because it happens every half circle. This is the only time that happens, is if cosine is 0. Because anything else, sine would happen at 0 and pi. That's the only other thing. Everything else, the positive and negative sign changes. Okay? So if you had those three answers, like if you had 0 plus 2 n pi, pi over 2 plus 2 n pi, and 3 pi over 2 plus 2 n pi, that's what I would take on a quiz. So don't stress out if that's what got wrong. Okay? It's just that it simplified it because it said this is a special case in which if I only take the smaller one and add n pi to it, it doubles that answer. So it's like you don't have to write it twice is the only concept. And then there was one other one, right, where the answer was, okay, so this one said find all the solutions of the equation on the interval 0 to 2 pi. So if it's secant x equals 2, I'm going to flip it, so it's cosine x equals 1/2. And then interval 0 to 2 pi is your entire unit circle. So this is almost exactly like the warm-up. Cosine is 1/2 at pi over 3 and at 5 pi over 3. And those are the only two you include because it gives you the interval. This one, 7, said find all the solutions on the interval again, 0 to 2 pi. So this time it says tangent squared x minus 1 equals 0. Tangent squared x would equal 1. Tangent of x would equal the square root of 1 with the plus and minus in front of it. So we're looking for everywhere tangent is positive or negative 1 on that unit circle. This is all the over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Don't forget your plus and minus. 4, solve the equation 2 sine of x plus 1 equals 0. I'd get 2 sine of x equals negative 1, sine of x equals negative 1/2. This time it didn't give me my interval, so I'm looking for where it happens on the circle for sine, but then I'm going to add 2 n pi. So sine is negative 1/2 in the third and fourth quadrant, and it's where it's out the over 6s. So it's 7 pi over 6, and it's 11 pi over 6, and to each of these I'm adding 2 n pi. Five, 3 cotangent squared minus 1. So this would be 3 cotangent squared x equals 1. Cotangent squared x equals 1/3. Square root both sides. Cotangent x equals plus and minus the square root of 1 over 3, which is 1 over root 3, which gets rationalized to root 3 over 3. And it's plus and minus, so it's everywhere on my circle. It doesn't, actually, this is cotangent, so it doesn't give you the interval, so I'm going to flip it to tangent. Actually, I should have done that before I rationalize it. So it's where tangent is plus and minus root 3. And then because it doesn't give me the interval, I'm going to look at negative to positive. And I would have gotten pi over 3 plus n pi, or negative pi over 3. This, actually, WebAssign allowed for the 2 pi over 3, because it also happens there. That's fine. It's not really wrong. Like, I would have taken either answer. It's not wrong to include the positive as long as you have the interval, because technically this would give you this, okay? So I would have taken either answer. So if you put in the negative and it marked it wrong, don't stress out about it, okay? That's the same thing. You just got to make sure you have 2 angles and then the half circle. 6 says cosine times cosine x minus 1 equals 0. So I would get cosine of x equals 0 and cosine of x minus 1 equals 0. So cosine of x equals 1. It doesn't give you an interval, so it's everywhere plus 2 n pi. Cosine of x is 0 at 0 plus 2 n pi. And cosine is 1 at, nope, sorry, cosine of, this would be your pi over 2. Pi over 2 plus 2 n pi and 3 pi over 2 plus 2 n pi. And then cosine of 1 is at 0 plus 2 n pi. So it just didn't like the way you wrote that. You can't put the 0 there. The 0 would be the other spot. Yeah. Okay. So the 2n pi is the same thing as 0 plus 2n pi, right? And then the larger value is this one. It just didn't give you the third option. Technically, this is still an answer, right? It didn't say n as an integer is constant. Yeah. Because it should be both. It just didn't give you that third option. Yep. Say that again.
Like the answer it shows there is plus n pi.
Because this would be the same as writing both of these. Does that make sense? It happens every half circle there. So if I wrote n pi over 2 and I added 1 pi, I get 3 pi over 2. And then I added another n pi, I get back to the top. So that's the only time that works, though, because it's the only time that your value, well, that's not true, because you could do it at 0 and pi for sine. It just took those two answers and put them into one by eliminating the other half the interval. Yeah. So quiz-wise, you can give me what's on the bottom because it's the same thing. And it's less confusing. But that's why it eliminated half that interval. Okay. All right. So 5.1 and 5.2 had the same bank of references. Okay. This is all of your identities, your fundamental identities. And then part of the quiz is going to ask you just to simplify what's there. And then the other part's going to ask you to verify what's there, where your left side has to equal the right side. I want to stress that you have to show your work on these. Obviously, you know if it gives you the left side equals the right side, what your answer is supposed to be. But without the steps in between, you will not get credit for the question. So the reciprocal identities are the ones we've been dealing with the longest, right? So this would be like secant of theta is 1 over cosine. Cosecant of theta is 1 over sine. Cotangent can be written as 1 over tangent, or it can be written as cosine over sine. And tangent would be 1 over cotangent, or sine over cosine. And if you need to work in the reverse, you can say that cosine is the same thing as 1 over secant, and and sine is 1 over cosine. So however you need to work those through, you want to make sure that you be able to replace those. Then came the co-functions. This is your partners that deal with complements. So if I said sine of theta, it's the same thing as the cosine of pi over 2 minus theta. And vice versa. Cosine can be replaced with, or actually it should be the other way around. Sine pi over 2 minus theta could be replaced with cosine. Then tangent went with cotangent. So tangent is the same thing as cotangent. God bless you. Pi over 2 minus theta. And cotangent is the same thing as tangent. Pi over 2 minus theta. And then cosecant went with secant. So secant is the same thing as cosecant. Pi over 2 minus theta. And cosecant is the same thing as secant. Pi over 2 minus theta. So you know that you can replace one with the other. Usually you're replacing the right side with the ones on the left for those cofunctions. Then came even and odd identities. Remember that cosine and its reciprocal function, which is secant, are the even ones. So if I said that the cosine of negative theta, it's the same thing as saying cosine of theta. And secant of negative theta is the same thing as saying secant of theta. Whereas, so these are the even ones. Whereas the odd ones, sine of negative theta is replaced with negative sine of theta. Cosecant of negative theta is replaced with negative cosecant theta. Tangent negative theta is replaced with negative tangent theta. And cotangent negative theta is replaced with negative cotangent theta. Then came the Pythagorean identities. So the one we know the best is sine squared x plus cosine squared x equals 1. If I divide them all by cosine, I get the next one, which is divide them all by cosine squared. I get tangent squared x plus 1 equals secant squared x. If I take my original and divide them all by sine, I get 1 plus cotangent squared x equals cosecant squared x. So remember, you can derive them if you get stuck. Take your initial one. Hopefully you have the initial one memorized. Take that initial one, divide everything by cosine, you get the tangent one, and then divide everything by sine, and you get the last one. Questions on the original identities? So obviously then you got to apply it, right? Some of them are going to say simplify, and you got to simplify, and some of them are going to say verify, where you got to get the left side to equal the right side. Everything that's on that is on Quizlet on the module underneath where it says 5.1 to 5.3 quiz review. So if you're a Quizlet person, okay, there's everything that's written there is on flashcards. Okay, just some examples. So these are the verifying ones. So pretend that the thing's not there on the right. This would be your simplifying. And then obviously if it's there, then it's your verifying. So if I had 1 plus tangent squared theta times cosine theta equals secant theta, what would you do? And there's more than one way to do this. Okay, so 1 plus tangent squared is in your Pythagorean identities. This could become secant squared theta times cosine of theta. Then what? Yep. This could be 1 over cosine squared theta times cosine theta. Then when your cosines cancel, you get 1 over cosine theta, which is secant theta, equals secant theta. You're always going to go all the way to the last step where the left side equals the right. And yes, some of them could be that easy. Okay, you could have also distributed this. It would have been a lot messier, but you can get there. Obviously, look for your trig identities first. Okay, how about this one? Cosine to the third plus sine squared times cosine equals cosine. What would you do? Janet. Move the cosine over? Okay. Like that? Okay, then what? Then take a cosine out. Yep, thank you. Okay, then what? Sine squared, cosine squared. That works. Okay, you could have also taken cosine out from the beginning, right? I don't think that it's any easier. I think they're both fine. Because then this becomes cosine theta times 1. It's like one less step, but honestly, it's not any different. Yeah, they're both right. Questions on that one? Uh-huh. All right, what would you do here? Okay. Change this side to make them what? Like sine over cosine or 1 over cotangent? Sine over cosine. super easy, right? So I am not saying they will all be that easy, but you could get an easy one. The biggest thing is don't give up, because the easiest one might be the last one for you, right? Like, don't get frustrated. If you get stuck, you need to keep going. Go back to the beginning. Remember your tricks, like moving from the denominator to the top becomes its reciprocal function. Combining into one fraction, you might need to change them so they have the least common denominator. You can cross multiply. Remember all those tricks, because they're going to come in handy. Any questions on simplifying or verifying? Okay. Then came what we were talking about in 5.3. Okay. Remember, you need to know your unit circle, obviously. You don't need to fill the whole thing in. To be honest, I probably wouldn't. I would probably give myself my little, like, over 6 is root 3 over 2 and 1/2. Over 4 is root 2 over 2 and root 2 over 2. And then over 3 is 1/2 and root 3 over 2. And then the tangents at those places would be root 3 over 3, 1, and root 3. And then know your signs. Like, other than that, you don't need, like, I don't need the angles for sure in degrees, okay? It would be a waste of time to fill out your entire thing. So remember that if it's got an interval, like 0 to 2 pi, parentheses should be there, that you're going to give everything that's on your static unit circle. Everything for sine, cosine, or tangent. If it doesn't say that, then for sine and cosine, you're going to add 2. That should be an n. It should be 2n pi. And for tangent, you're going to add n pi. And tangent, you're going these values. Negative pi over 2 to positive pi over 2. But sine and cosine, you're using your whole circle.
And then for cotangent, it would be the same thing, right?
Yeah, because you could flip it. Yeah. Like, I would probably flip it so you don't have to know the other reciprocal. I mean, it is just the reverse of that, but I would probably flip it. So if you had something like 4 cosine squared x minus 3, you're going to make that 4 cosine squared x equals 3. Divide both sides. And then square root both sides. I'd get plus and minus the square root of 3 over 4, which is the square root of 3 over 2. So I'm saying plus and minus root 3 over 2, and this is the benefit of knowing this stuff over here. That's all the over 6 is. The over 6 is pi over 6. And it didn't give an interval, right? Plus 2n pi, 5 pi over 6.